Okay, welcome back to example number 4 in polar coordinates. We're working on conversions, and this second example is we're going to be looking at converting 2 comma 5 radians into rectangular coordinates. And since I'm a diagram guy, I think the first thing I want to do is figure out where is 5 radians. I mean, is that quadrant 1, 2, 3, 4? So here's what I did. I took 5 number of radians, I multiplied by 180 over pi, and I get 286 degrees and change. So we're clearly in quadrant 4, right? This would be 0, 90, 180, 270. So clearly we're in quadrant 4. Okay, and to get into rectangular coordinates, we're going to need the x and y. So we're pretty much going to be using these relationships, which of course comes from the basic trig that we've done many times in the past. So x equals r cosine theta, and we simply put the numbers in. R, of course, is 2. In this case, r is not radians. R is the little r, which corresponds to the radial distance we're going out. Cosine of 5. And again, that's in radians. What we're going to need to do is we're going to need to have our calculator in radian mode. Okay, so check it's in radian mode. I'm checking mine. And yes, I am. And now I'm simply going to type 2 cosine 5. 2 cos 5. And I hit the enter key. I get 0.567. 32. 43. 709. Of course, this is an approximation. Okay. So I'm going to probably round it off a little bit, but let's go ahead and first compute the y. And y, again, as we've seen in the past, sine is y over r, so therefore it's r sine theta. And put the numbers in, and 2 sine of 5 radians. Again, I want to be in radian mode. I guess I can put it here. So I'm going to go 2 sine 5, and I get negative 1.9178485519, yada, yada, yada. And, this makes me feel good because don't forget, r here is the y value, rather is negative, and x is positive. So, knowing that, so altogether then, xy equals, and I'm going to round off to some reasonable amount. Let's round off to nearest 3, let's say. So x is 0.567, and y would be negative, don't forget the negative, 1.918, and that would be our answer in rectangular coordinates. Okay, so, what we always need to do is, in a question, we need to understand what the coordinates are in terms of radians of degrees, and we need to, of course, know what the rounding is. So that, of course, would depend on the individual question. But this is the plan, and what we're going to do is we're then going to go into changing equations in rectangular form into polar form, and vice versa. And then we'll take a look at some of those graphing problems that I assigned on those nice grids with all the little circles on them to indicate how far we were going out. You really need to do this on your calculator to get a certain amount of familiarity, because there are some interesting things that come into play here. Okay, so see you in the next one, and that's it.